হ্যাঁ সিদ্ধার্থ, আমি দেখেছি তোর মেলটা। আমি এমনি তাহলে আমি কি ভাইবার ডেট ঠিক করব? ঠিক আছে, আমি জানাচ্ছি। হুম, ঠিক ঠিক আছে, আমি দেখছি ভাইবার। তোমরা কি রেকর্ডিংটা পাঠিয়েছো আমায়?
না।
রেকর্ডিংটা পাঠালে তাহলে আমি মেটেরিয়ালে আপলোড করে দেবো।
ঠিক আছে, ক্লাসের শেষে পাঠিয়ে দেবো।
আজকেরটা রেকর্ড করো, কিন্তু আমার দিক থেকে এখন রেকর্ড করতে দেবে না।
ঠিক আছে স্যার।
আমরা কি এবার শুরু করবো? 10 মিনিট তো হয়ে গেল।
ইয়েস স্টার্ট করুন স্যার।
We have discussed about manufacturing property, no?
Yes sir.
So I think from the list, it is quite transparent to you. That for cold formability, what are the important points? Yield point, strain hardening, elastic modulus, ductility. Ductility is very important when formability is concerned, because here force is applied and material flow. Otherwise, it cannot take the required is very low and it will not allow any stick flow, then it is difficult to form or to give the shape as required by pressure or force. Because in case of formability, by the application of force, actually shapes are taken. Is it clear or not?
Yes sir.
And in case of hot formability, actually temperature is high, and therefore there another important property, thermal expansion, thermal conductivity, and strain rate sensitivity are also relevant material property to be considered. And even at high temperature, oxidation problem may take place, therefore chemical composition is important. Uh, what my suggestion is that as a designer, you have to look that what are the property in case of cold formability and hot formability, and what extra or additional property is important in case of hot formability, and why. In case of hot formability, temperature is very high. If thermal conductivity is very high, so temperature will be lost very fast and material get cold. Therefore, it is important. And thermal expansion, expansivity also important, because during the temperature rise, if metal expands, then again it will be difficult. So you have, as a designer, you have to identify what may be the relevant material property related to a certain manufacturing process, and what appropriate value for those properties should be taken. Based on that, you have to select the material, or rather, the reverse also may be true, that depending on the material selected uh, to fulfill the other requirement, you have suppose already selected the material, then what suitable manufacturing procedure, or which manufacturing procedure is rather.
এই তোরা কি স্যারের কথা ঠিকঠাক শুনতে পাচ্ছিস?
একটু প্রবলেম হচ্ছে বড্ড, কেটে যাচ্ছে।
স্যারের আওয়াজ শোনা যাচ্ছে না আর।
Are you hearing me now?
হ্যাঁ স্যার, এবার শোনা যাচ্ছে, কিন্তু 2-3 মিনিট আপনি কি বলেন শোনা যাচ্ছে।
What I am telling, look, in cold formability, there are certain material properties, relevant material properties. And in hot formability, some other additional properties are there. Some common property is there. Along with the common property, some special property like thermal conductivity, strain rate sensitivity, thermal expansion, chemical composition. As a designer, you have to think that when temperature is raised, then at high temperature, material becomes highly sensitive to strain rate compared to normal temperature. Therefore, the strain rate sensitivity may not be so important in case of cold formability, but it is very severe in case of hot formability. Do you appreciate this?
Yes, sir.
In case of hot formability, thermal conductivity, thermal expansion, these have certain role. If higher conductivity, then heat will be lost very soon. So temperature may be lost. Chemical composition is important because at high temperature, tendency for oxidation will be increased, or reaction with atmosphere will increase tendency. So depending upon the manufacturing process, certain material parameters are important which a designer has to think of, consider. And what material property related to what manufacturing process, a designer should have a wide spectrum of awareness. Do you appreciate this or not? Hello?
Yes, sir.
And sometimes knowledge may be required for the reverse way. Suppose you have already selected a material, considering other aspects. Now you are going to select the manufacturing process. If you know the material property, relevant material property, then it will be helpful for you to select suitable material manufacturing procedure. So either to select material related to a manufacturing process, or to select a suitable manufacturing process related to a material, you should have know this information, this awareness. Is it true or not?
Yes, sir.
And actual total information will be available in the book. My request will be to go through the book to get a detailed rather correlation, material property and manufacturing process. This is an important area for mechanical engineer. In design course, I will just hint you, or rather give you the relationship why it is important. Is it understood? Similarly, you have to know what is the turning process and what property is required. Milling process, drilling process, shaping process. So once you will go through different manufacturing process in your undergraduate courses, third year or fourth year, there you will have the knowledge what are the aspect of manufacturing process, different aspect, and how they are related to material property. Suppose in machining process, one of the demand to get a good surface finish after machining. Now designer has to know what is the material property which controls the finishing quality of a product by a certain machining procedure. If he knows, then only he will be able to select appropriate material concerned with particular manufacturing. So this knowledge in this area, material property and manufacturing process, is an important input for designer. Do you appreciate this?
Yes, sir.
Here I have tried to list some of the material property along with the manufacturing process. You will go through this, and why this particular property is related to a particular manufacturing process. For that you have to go through a book, because you have to know the manufacturing process itself, and then you can connect why a particular material property is related to certain manufacturing process. So I have already given this classification, no? Probably.
Yes, sir. Yes, sir.
Look, metals and alloys, this is a very large group, and their basic property are their crystalline structure. This is a gross category of metal and its alloy. Mainly crystalline structure, good thermal and electrical conductivity, high strength and high elastic modulus. High strength means the ultimate stress or failure stress is quite high. And also this metal can sustain its capability or strength at high and low temperature. Ductility is also good for a class of metal. Some of the metals are brittle, but also within the metal group, ductile materials are available. And also metal can be alloyed to improve material property. Can be introduced new material property by alloying and sometimes by heat treatment. And they are poor against corrosion. This is the basic general property of metal and alloy. Ceramic and glasses, inorganic materials consisting of both metallic and non-metallic elements bonded together chemically. Metallic and non-metallic elements bonded together chemically gives you the ceramics and glasses. Ceramic may be crystalline or may be non-crystalline. When non-crystalline, then it is called glasses. What is the important feature of ceramic? High melting point and high chemical stability. Chemically, they are very much inert. Ceramic material. They have high hardness, high moduli, and high temperature strength. Temperature strength or strength against temperature, high temperature is better compared to metal. So the ceramic products are generally preferred when high temperature application is there. But they are poor in ductility because ceramic materials are very much brittle in nature. And they are also poor in electrical conductivity. But they have a high strength on compression, rather they are weak in tension. Polymers are another group of mainly organic material and consists of long molecular chain of networks. You have already studied the polymer material. Polymers are non-crystalline, but some consists of mixture of both crystalline and non-crystalline. Their importance is, polymers are important because very low density. Rigidity is low, but strength sometimes can be very high, even with low density. Therefore, where we require some lighter material but a moderate strength, there we can use polymer. Polymer are poor in electrical conductivity. Corrosion resistance is their important property. So these are the general properties. The last line is important. They have a good strength to weight ratio. As because of their density is very low, so they maintain a very good strength to weight ratio. Composite materials actually combination of any two we said above. It is generally two part. One is a matrix, another is a reinforcement. And matrix can be metal matrix can be ceramic matrix, So matrix can be varied, and there must be some reinforcing element within the composite. And composite can be also particle layer wise. There are several variation in the structure. And important property of composite that by mixing two, you have one group matrix, another group reinforcement. And ultimately the composite will be generated, cannot be grouped either in the matrix group or in the they will develop a new material different from matrix and reinforcement, but the property generated is a good combination of matrix and reinforcement. So when you require that two conflicting property is to be accommodated in a single material, two conflicting property is to be accommodated in a single material, then you can use matrix giving or leading to certain property, reinforcement leading to certain property, and you can combine it and you can generate your desired material. By this, today actually lot of research is taking place in the composite area, and to generate by changing the composition, by changing the structure, and optimum material property can be developed. And for that, a particular composite can be designed. Composite materials are designed now. That I require certain kind of property, and to generate that kind of property, I have to this kind of matrix and this kind of reinforcement and this type of structure. And if somebody can implement this, then he can develop a material which rather consists the desired material property. So four gross group: metal, ceramic, polymer, and composite. Other special type of materials are there, smart materials are there. I think I have told this part also, no? Ferrous, non-ferrous?
Yes, sir.
And okay. Cast iron?
और थोड़ा सा बचल है बनाएंगे हाँ
Hello?
Yes, sir.
Yes, sir.
Grey cast iron হয়ে গেছিল?
না স্যার আগের দিন তো হয়নি।
So cast iron have different groups, no? Cast iron, gray, white, nodular, malleable, and compacted. First thing, cast iron is a brittle class of material, basically. And carbon present in the material, I have already told, when percentage of carbon present in the iron more than 2.1%, then only it is under the class of cast iron. Otherwise, it will be under the class of steel. If the percentage of carbon is below 2.1%, then it will be under the steel. More than 2.1%, cast iron. And you know that material property of iron depends on the percentage of carbon. Higher the percentage of carbon, higher the strength and lower the ductility. Note my statement. Higher the percentage of carbon, higher the strength. Strength will be improved, but ductility will be reduced. So what will happen? By increasing the percentage of carbon, the material is approaching towards brittle material. The cast iron generally assumed to be a brittle material. Here plastic deformation will be very low, but strength is good. Damping ability is very good. Because of damping ability, it can absorb the vibration. Higher thermal capacity, higher castability. We have already studied the castability, so it is a good material for casting process. And stability at high temperature is very good. Cost-wise very low, but machinability is not good, because by cast iron the surface finish will not be good, as because it is a brittle material. Lower electrical and thermal conductivity, lower plasticity. Generally, these cast iron are used for machine parts, mainly for machine bed and structure. Under the cast iron, there are 5 groups I have already, because iron can be present in the carbon in different form, either in flake form or in a nodular form. When flake form, look here, the graphite flake tips, it is present in here as a graphite flakes, and therefore because of this type, it is brittle in nature. Plastic deformation is not allowed by this material for grey cast iron. But when it is nodular, then a little bit plasticity can be allowed. Because of this nodular shape of the carbon, because of this nodular shape of this carbon, ductility increases. So sometimes it is called ductile cast iron, as because ductility is better compared to grey cast iron. It is white cast iron because of the color of the carbon present here. It is in the form of cementite. Cementite, very hard and brittle, very hard and brittle. Malleable cast iron. What is malleability? It is the capability of a material that it can be formed as a sheet. Thickness can be reduced to very thin level. It is only possible if there is sufficient ductility and also strain. So malleability is a property which is offered by a material when its strength and ductility is in a good combination, which is true for this malleable cast iron. So if somebody asks that is there any cast iron which can be formed into a sheet, it is rare, but you can answer, okay, malleable cast iron is there, percentage wise, composition wise, it is given. And it is compact graphite iron, compact graphite iron. The important property is relatively high thermal conductivity. High thermal conductivity, though the actual general property of the cast iron is very poor conductivity, but in case of compact graphite carbon, percentage it is very high, 3.1 to 4%. So here I have shown you certain application of cast iron, car parts, pipes, leads, foundation for big machines, bridge, building, etc. Another important group and most important group for ferrous material is steel. Steel, actually the general definition, alloy of iron carbon, alloy of iron carbon. When it is alloy, then it should be in homogeneous form. It is in homogeneous form. Iron carbon alloy. And certain other alloying element may be present. I have already told that if total percentage of alloying element exceeds 10% by weight, then we say it is alloy. Otherwise, we say low alloy if it is less than 10%. And within the low alloy, there are medium carbon steel, high carbon steel, low carbon, medium carbon, high carbon, specified by their percentage of carbon present. When it is below 0.25%, it is low. Between 0.25 and 0.6, it is medium or mild steel, and high carbon where 0.6 to 1.4%. And high alloy when chromium, specifically, chromium more than 11%. Is the classification clear?
Yes, sir.
Under low carbon steel, it is called sometimes plain carbon steel. Very low content of alloying element, but small amount of manganese cannot be avoided. And as because here percentage of carbon is very low, look the third property, that low responsiveness against heat treatment, as because low percentage of carbon present. But it has good weldability and machinability. Here I have listed some special steel. You will go through it. I will not read it out. It is for medium carbon steel. And this is for high carbon steel. Their application and their composition, special composition are given. Finally, a table. Now, I will discuss an important area, alloying element on steel. By introducing some new element into steel, we can improve certain property. Here I have listed the alloying component and their contribution in steel. Class নিচ্ছি বেরিয়ে ফোন করছি Look, manganese increases strength and hardness, but you have to note it decreases ductility and weldability. But phosphorus increases strength and hardness and decreases ductility again. Sulfur decreases ductility. Weldability increases. Silicon, one of the principal deoxidizer used in steel making. So it gives you buffer or support or resistance against oxidation. Copper, detrimental to hot working steel, beneficial to corrosion resistance. So when we require a structural steel to be in saline environment, ocean, sea, there we prefer to mix copper because it increases the corrosion resistance. And nickel, very important alloying element, increases the hardenability and impact strength of the steel, and another also high temperature retention of the strength, nickel. So nickel alloys are preferred for high temperature application. Molybdenum increases the hardenability, enhances the creep resistance. Look, against creep, molybdenum contributes a lot. So where creep phenomena may appear for the steel or component to be used, there we prefer molybdenum as alloying element.
Sir, hardenability টা কি স্যার?
হ্যাঁ বলো।
স্যার hardenability টা কি একটু বলবেন?
Hardenability হচ্ছে hardness, একটা property of a material. I have already declared that resistance against scratch, indentation is called hardness. Isn't it?
মানে স্যার হার্ডনেস টা hardenability?
হ্যাঁ।
ওকে স্যার।
Titanium is also corrosion resisting. Aluminium alloys are there. Aluminium alloys are preferred because it decreases the weight. So aluminium alloy will give you good strength to weight ratio. So you will go through different alloying elements and their contribution into steel. Look, you will try to identify what specific property of the steel can be improved by what alloying element. Because this knowledge will be support for a designer to select appropriate alloying element. Appropriate alloying element, because in the market, alloy are available. Alloying element are available. But which alloy a designer should select, that depends on the specific application, because from the specific application he can sort out what property is required for the component. If it is in a corrosive medium, then anti-corrosive steel. If it is applied against high temperature, then material which can sustain its strength at high temperature, which alloying element helps it. If creeps are probable, then creep resistance against creep is to be improved, and then what particular alloy. If lightweight is demanded, then by how alloying I can manage the steel. alloying is an important tool at the hand of designer to fit the material as per requirement. What you have to do, you have to prepare a material alloy element list and their contribution into special steel. Is it understood?
Yes, sir.
Yes, sir.
A special class of steel is stainless steel, mainly contributed by chromium. And basic importance of stainless steel, it is very rather resistance against reaction with environment. And depending on the phases of the steel, it can be ferritic, martensitic, austenitic. If you have you studied iron carbon equilibrium?
Yes, sir.
Hello.
Yes, sir. Yes, sir.
Yes,
So
sir.
I think you know ferritic, martensite, ferrite, austenite.
Yes, sir. Yes, sir.
This
Yes, sir.
and duplex is another kind of steel where two phases are present. Here ferrite plus austenite, but sometimes ferrite plus benite, and sometimes multiplex steel also ferrite, benite, and austenite can be there. And you should know from iron carbon diagram, you also already have known that each phase gives you different grade of property. There is a wide difference in the material property for ferrite phase and austenite phase. I think you already know that, no? Hello?
Yes, sir.
So, you know, depending upon the phases and percentage of carbon and temperature, phases are available within the steel. By changing the percentage of carbon or by changing the temperature, we can change the phases and their percentage wise contribution in the steel. You know it, no?
Yes, sir.
Here a material list is given. Their standards designation by AISI, their composition and their material property are there. Such kind of lists are available from where you have to select your material. And a designer should be capable to consult a material catalog. What my final suggestion is that a designer is to be capable to consult a material catalog. He has to rather go through several material catalogs and have to identify his requirement from the available steels. Now, heat treatment of steel. I have already told you, as you have already gone through the iron carbon equilibrium diagram, you know that depending upon the temperature and the percentage of carbon, phases are present inside the material, and depending upon the percentage of different phases present inside the steel, property will be developed. So by changing the phases, by changing the microstructure within the material, we can change the property of the steel. You agree or not? Hello.
Yes, sir.
And first of all, you have to know what are the parameters representing the microstructure. First of all, what different phases are there? Second, how they are oriented. What is the grain size? What is the grain orientation? These things actually gives you the microstructural parameter. And by changing this microstructural parameter, we can change the material property like hardness, strain, toughness, ductility, elasticity, etc. Composition remaining fixed. Composition remaining fixed means percentage of carbon suppose fixed or other alloying element fixed. Is there any scope to change the material property just by applying temperature and then cooling to normal temperature? The answer is yes. And the name of the process is called heat treatment of steel. Because by changing the temperature from the present microstructure, we can rather generate new microstructure. Because when we will increase the temperature, if we consult from the iron equilibrium diagram, we will do that it will undergo different phases, isn't? If you look at austenite will be at the higher temperature range, no?
Yes, sir. ওটাই ভেঙে martensite and ferrite হয়।
My question is that if we raise the temperature, then metal or the steel will undergo or will pass through different phases.
Yes, sir.
And now, depending upon the time, conversion of the total composition present to some phases depends on. Ultimately, we can assume that if we raise the temperature of a given steel and then cool it, ultimately, what will be the final microstructure? That depends upon at what rate we have heated the element, up to which temperature we have heated the element, and when cooled, at what cooling rate we have reduced the temperature. And at high temperature, what time we have allowed to stay. So if I define in this way, heating rate, final temperature, dwelling time, staying at a particular temperature through certain time is called dwell, and then cooling rate. Shall I repeat?
Yes, sir.
You try to visualize the heating process. I am heating to certain value. I can make it very fast, I can make it very slow. So heating rate, I have to stop up to a certain value, maximum temperature raised, then allow to stay the material at different temperature for different duration, dwelling at different temperatures, then reduction of the temperature to room temperature with certain rate, cooling rate. So heating rate, maximum temperature, dwelling duration, cooling rate. These are the parameter of heating and cooling for the material or heat treatment process. Shall I repeat? Hello? Hello?
Yes, sir.
So ultimately, depending on these parameters, where it will be ended or what will be the final microstructure at the end, that will depend. Do you agree or not?
Yes, sir.
Or if we know the iron carbon equilibrium and TTT diagram, you know TTT diagram, no? Time temperature transformation. You have studied in your heat treatment process, no? TTT diagram.
Yes, sir. Yes, sir.
So depending on these final phases, in which percentage what phases will be present, what will be the grain size, etc., will depend, and therefore property will depend. If we make a faster cooling, if you try to recollect your TTT diagram, that it will fall very fast, then at the end in the left side martensite is present, so amount of martensite will be more. Do you agree or not? Hello?
Yes, sir.
Yes, sir.
And we know that martensite is very hard. So if we cool it very fast, we will have huge large amount of martensite. naturally leading to hard material losing ductility. So in the heat treatment process, what is the cooling rate? That will dictate final microstructure we'll have. And now we can say this knowledge can be used to control the heat treatment parameter as our requirement. We require hard, okay, we make it fast cool. No, we require ductilities, very slow cool. No, optimum, a good combination, intermediate cooling rate. We do not require austenite. We will not raise the temperature beyond 723. So if we have a knowledge on iron carbon equilibrium, transformation issues, microstructure, and their relation to material property, then designer also can suggest a suitable heat treatment process. He used a particular grade of steel. Particular grade of steel is used, but designer can suggest additionally a suitable heat treatment procedure to control the material property as per his requirement for the product specifically. For that, you have to know the different heat treatment process, their name, their final effect, etc., etc. Is it clear why heat treatment, knowledge of heat treatment is required by a designer? Hello?
Yes, sir.
So here 4 processes are generally mentioned: annealing, normalizing, stress relieving, and hardening or quenching. In every process, you will try to identify what will be the maximum temperature, what is the cooling rate, fast or slow. And also you have to know how cooling rate can be physically controlled by changing the media. Because air cooling is possible, water cooling is possible, and sometimes special cooling medium using certain oil. Because depending on the specific heat and conductivity of oil or water or air, cooling rate will be controlled. Is the idea clear? Hello?
Yes, sir.
So in this heat treatment process, you will identify, you will go through the texts are given, what is the requirement or rather desire, what property we like to have, and how it is controlled by controlling the heat treatment process. Your notice will be what is the cooling rate, what is the temperature up to which it is heated, fast cooling or slow cooling or intermediate cooling, and what will be the final property. I will say about case hardening. I think you will study these processes: annealing, normalizing, stress relieving, hardening, and tempering. In the text, it is given what is the cooling rate and what is the temperature it is raised. Case hardening is another issue. Instead of giving strength throughout the component, sometimes in special application it is required that you have to make the surface with very high strength. You require the strength on the surface, so which is called surface hardening or case hardening. And it is observed in practice that by adding cyanide or nitrogen on the surface, which is called nitriding or cyaniding, we can add strength to surface. So these are known as case hardening process. Case hardening process. Here, strength of the material will be improved up to a certain thickness, not throughout the component, because we require that high strength at the surface only, not throughout the component. Surface strength is to be increased to avoid failure in wear, tear, or etc. etc. There, in some cases, we require strength in the surface. Case hardening process or surface hardening process are there, either nitriding or cyaniding. They are available. Is it understood?
Yes, sir.
Now, for designer, it is very important to know the designation of steel, because steels sometime will be available by a name only. From the name are given following certain code, certain standard rules. If designer knows that rules, then he can interpret from the name of the steel what specific property or specific composition is given for that steel. Now, these standards are also vary from country to country. As a designer working internationally or country level, you have to face different standard for designating a steel. It may be American standard, AISI, or Society of Automatic Engineers, SAE. AISI and SAE, two types of designation or nomenclature are possible from American standard. British standard is given by mainly by EN40. It is a category of steel, and EN40 represents a special class of steel. If you know the rule of British standard, how it define or designate a steel, then you can interpret EN40. German standard are given by DIN, DIN, DIN series. DIN category or DIN designation means it is a class of German steel. Mainly this followed by German manufacturers. Similarly, Japanese are there, JIS. Indian standard is given by IS. French are given by F0. Similarly, other are there. Look, for SAE, some hints, a slide I will discuss. For SAE, look, 1XX. If it starts with 1, it is plain carbon steel. If it starts with 2, it's a nickel steel. 3, nickel chromium. So, from the first letter of the SAE designation, somebody can interpret what composition, what alloying elements are there. Is it a plain carbon steel or nickel steel, nickel chromium, molybdenum? Which is the main alloying element in the steel is identified by the first number. Other numbers has other meaning. Other numbers will give you the strength. Another designations are typical ASTM. ASTM designations are there. Look. Unalloyed steel, when it is plain carbon steel, it is given C45. What is meant by 45? 0.45% carbon. 0.45% carbon. So C100 will represent 0.100% carbon. Sometimes alloyed steel are designated by this 10 chromium, molybdenum, 910. So when it is 10, actually percentage is given by 100. So for what element, by multiplying which factor percentage will be given, there is a list. For certain elements, the percentage is multiplied by 100, then given as the number. Suppose chromium is a member, percentage of which will be multiplied by 100 and then given aside is 10 chromium. If you know that for chromium percentage multiplied by 100, then only from 10 you can identify the actual percentage of chromium present is 10 by 100. But it is not true for molybdenum. For molybdenum, the factor is 4. For molybdenum, the factor is 4. No, sorry, I am wrong. The first number is given here 10 for carbon, so that is 100. For chromium second, then it is given by 9 by 4, and for molybdenum it is 10 by 10. So you have to know that for carbon, the percentage is multiplied by 100. And there are list of such materials. What will be the multiplying factor? That is given in the next slide probably. Here it is given. Another kind of, it is IS code, Indian standard, that Fe and A value. Look, Fe, capital E. Capital will be replaced by certain number, and that will represent the yield strength of the material. Fe 300, Fe 300. That means it is a steel, plain carbon steel with 300 MPa yield stress. 300 MPa yield stress. So there are different types of designation given in different standard, and from the catalog and from their brochure, you have to know. Look here, Fe 410 CUK. Fe 410 by Newton per millimeter square. This is the tensile strength of the material. Cu is the special alloying element mixed, and Ka represents for killed steel. It is another processing of the steel. Here I have given you some designation. Look, that list I have shown here. That chromium, copper, nickel, manganese, silicon, and tungsten, those will be multiplied by 4. But these will be multiplied by 10, and these will be multiplied by 100, and also carbon is multiplied by 100. So from, if you know this list, then you can identify what is the percentage of composition in this. Look, 25 Cr4 MO2 G. Can you say what is the percentage of chromium here? 25 Cr4 MO2 Mn2 or MO2 probably G. Can you say what is the percentage of chromium?
1.
Yes. So by designation, sometimes you may have to interpret the actual composition, and you say then how by knowing the composition I can estimate or assess about the property. Then you have to know property versus alloying element, what I have already discussed. This knowledge will help you, and sometimes you will get material with their material property like Fe 400, Fe 300. This knowing the designation of steel by different standard is also an area where designer is to be aware, or he has to consult the catalog for the standard given. Is it clear to you? Hello?
Yes, sir.
So I think this is the last slide. So I have completed the second presentation. Do you have any question? কেউ যদি কোনো কিছু বুঝতে না পারো ক্লিয়ারলি বলতে পারো। মানে শুধু ক্লাস করলে হবে না, তোমাকে এর সাথে কিছুটা বই ফলো করতেই হবে। আমি শুধু তোমাকে লাইনটা ধরিয়ে দিতে পারি যে in which line you should go through the book or what information you should pick up from the book. কেউ বুঝতে অসুবিধা থাকলে কোনো পার্টে বলো। মেটেরিয়ালের উপর লেকচারটা শেষ হলো। আছে কারো কোয়েশ্চেন? আব্দুল,
ইয়েস স্যার।
তুমি বুঝেছো পুরোটা?
লাস্টেরটা একটু প্রবলেম হলো স্যার, মানে বুঝতে পারলাম না স্যার।
ওটা একটু ধৈর্য ধরে লিস্টটা দেখবে। দু রকম ভাবে you can designate steel in two approach, one for by composition, another by property.
ওকে স্যার।
এবং রুলগুলো ডিফারেন্ট স্ট্যান্ডার্ডের জন্য ডিফারেন্ট টাইপ, এর কোনো মানে ইউনিফর্ম ন্যাচারাল রুল নেই। দেখালাম ইন এসেই আমেরিকান স্ট্যান্ডার্ডের ক্ষেত্রে ফার্স্ট নাম্বার ওরা যেটা স্টিলের দিয়ে থাকে সেটা হচ্ছে কম্পোজিশনটার বেসিক এলিমেন্টটা বোঝানোর জন্য। প্লেন হলে 1, নিকেল হলে 2, ক্রোমিয়াম হলে হয়তো 3। ফার্স্ট নাম্বারটা থেকে এসেই স্টিলের ক্ষেত্রে ওইভাবে বুঝতে হবে। আবার আই স্টিলের ক্ষেত্রে দেখলাম যে এলিমেন্ট ওয়াইজ ডিপেন্ড করে কার জন্য মাল্টিপ্লাইং ফ্যাক্টর কত হবে, তার পার্সেন্টেজকে সেই ফ্যাক্টর দিয়ে মাল্টিপ্লাই করে তারপরে ওই নাম্বারটা লিখতে হবে। ক্রোমিয়ামের গায়ে 4 লেখা আছে, ক্রোমিয়াম Cr4, মানে হচ্ছে ফ্যাক্টরটা হচ্ছে আমরা জানি ক্রোমিয়ামের বেলায় 4, তাই 4 কে 4 দিয়ে ডিভাইড করলে ক্রোমিয়ামের পার্সেন্টেজটা পাবো। তুমি যদি রুলটা জানো তাহলে তুমি এটাকে ডিকোড করতে পারবে। ইট ইজ এ কনসেপ্ট অফ কোডিং এন্ড ডিকোডিং, তাই না? কোডটা না ডিকোড করতে পারবে। আর কোড জানতে গেলে তুমি নেট থেকে একটা স্ট্যান্ডার্ড বার করে নাও, তার ডেজিগনেশন প্রসিডিওর বার করে নাও। আমি যতটা পেরেছি সবটা তো দেয়া যাবে না, প্রেজেন্টেশনে দিয়েছি, এর বাইরেও বই থেকে বার করে তুমি যদি কোডিংটা শিখে নাও কি রুলে কি হচ্ছে, তাহলে ডিকোড করতে পারবে। অ্যাজ এ ডিজাইনার তোমার ক্যাটালগ থেকে বুঝতে হবে যে হোয়াট পার্টিকুলার প্রপার্টি ইট উইল পজেস, আর তুমি অ্যাপ্লিকেশন ওই জানো তোমার কোনটা লাগবে, তবে তো সিলেক্ট করতে পারবে, তাই না? আকাশ, আকাশ কুমার সিং, অরণ্য, অরণ্য শুভ্র নস্কর,
ইয়েস স্যার।
তুমি কি বুঝেছো পুরোটা?
হ্যাঁ স্যার, স্যার মাঝখানে আমার একটু ওই নেটওয়ার্কের প্রবলেম হচ্ছিল, রেকর্ডিংটা আরেকবার একটু দেখতে হবে আমাকে স্যার।
ঠিক আছে। আশের, আনোয়ার, have you understood?
Yes sir.
অয়ন ঘোষ,
ইয়েস স্যার।
তোমার কোনো প্রশ্ন আছে?
না স্যার, মোটামুটি বুঝেছি।
বিক্রম ঘোষ,
স্যার বুঝেছি স্যার, তবে কোডিংটা একটু মানে প্র্যাকটিস করতে হবে ওই পার্টটা।
প্র্যাকটিস মানে ওটা একটু দেখবে। আমি তো
হ্যাঁ,
এখন সময় তোমরা তো তোমার মেটেরিয়ালটা যদি আগে দেখতে সুবিধা, আর কিছুটা নেট থেকেও পাবে, বই থেকেও পাবে কিছু। বিশ্বজিৎ, বিশ্বজ্যোতি,
হ্যাঁ স্যার।
বুঝেছো?
হ্যাঁ স্যার।
দেবজিৎ,
হ্যাঁ স্যার, আমাকে আমাকে একটু দেখতে হবে, আমার আসলে আগের দিন কামাই হয়েছিল, আমাকে ওই জন্য পুরোটা একবার দেখতে হবে।
আচ্ছা দেখে নাও।
ইয়েস স্যার।
দীপজিৎ পাল,
ইয়েস স্যার, বুঝেছি স্যার।
জগদীশ,
হ্যাঁ স্যার, ঠিক আছে।
এম কে, বাবা কে এম কে কে এম কে তো নামও দেয়নি, নিজেও নেই। প্রিয়াংশু, রাজু বর্মন,
ইয়েস স্যার।
হ্যাঁ বলো তোমার যদি কোনো কনফিউশন থাকে।
হ্যাঁ স্যার, বুঝেছি।
আচ্ছা, ঋতিকেশ,
ইয়েস স্যার।
হ্যাভ ইউ আন্ডারস্টুড?
ইয়েস স্যার, মোটামুটি ক্লিয়ার স্যার।
সাহেব রায়,
হ্যাঁ স্যার, বুঝেছি।
এটা কি সৃষ্টু দেব?
শীর্ষ স্যার। ইয়েস স্যার, বুঝেছি, একটু তাও বই দেখতে হবে মনে হচ্ছে।
আচ্ছা, ওয়াসিম,
ইয়েস স্যার, বুঝেছি।
সোহেল,
হ্যাঁ স্যার, মোটামুটি বুঝেছি, বাকি একবার দেখে বলতে হবে।
সৌম্যদীপ,
হ্যাঁ স্যার।
বুঝেছো না? তোমার কোয়ারি থাকে
স্যার
বলতে হবে।
লাস্টের স্লাইডগুলো একটু দেখতে হবে।
আচ্ছা, সোহন,
হ্যাঁ স্যার, বলুন।
তুমি বুঝেছো? তোমার কোনো কোয়ারি আছে?
না স্যার।
শুভদীপ, উৎকর্ষ, উৎকর্ষ, উৎকর্ষ,
হ্যালো স্যার।
হ্যাঁ তুমি কি বুঝেছো?
হ্যালো স্যার। হ্যাঁ স্যার, বুঝতে পেরেছি, নেটওয়ার্ক চলে গেছিল, বলতে পারি।
ঠিক আছে, থ্যাংক ইউ। আমি বৃহস্পতিবারের জন্য মেটেরিয়াল আর এ পাঠিয়ে দেবো। ঠিক আছে।